everybody. This is probably an episode of Randos United. We have Ginger Bill and me, Sam Adams, and we're going to be talking about the Sir Roger Penrose, William Lane Craig debate. And this is not new. When did this happen? This happened in October 4th, 2019 was when it was released. So it's, over 2 years old at this point. But I thought it was a really cool video. A little frustrating, but also very interesting. And Jacob twisted our arms enough to get us to talk about it. And so here we are. So Bill, do you want to introduce yourself?
Yeah, I am Bill, Ginger Bill. Maybe go see him on the Discord, on the Bridges of Mean Discord. So hello, everybody. Anyway, if you're not seen me before. But yeah. So yeah, Jacob's just kind of roped us in saying, hey, you guys, we'd love you to discuss about this because you two would be perfect for it. And I went, okay, let's try and do this. So for me, people background, I've got a physics background, physicist by profession. And so clearly I'll be able to kind of talk about stuff like Roger Penrose has been doing. So I guess there. And I guess you are getting more of a theological background in yourself there in that sense as well. I know you're also a statistician.
I'm a statistician professionally, work in kind of healthcare and biostatistics mostly. And I guess I know about theology and I know about Neoplatonism. But I actually don't know super much about physics. But we'll see what we have to say.
That'll be fine. I can always help.
Yeah. All right. So let's see here. Should we start off with kind of Sir Roger Penrose introducing introducing what he calls the three worlds and the three mysteries.
Yes.
So let's and let me know if the audio is not working. Hopefully this works right off the bat. I think it will, but let me know. All right. Do you see it?
I see it, yes.
All right. And I believe that it is recording this. So here we go. Oop, that's on 2x. So if anyone listens to us at 2x, that would be 4x, which would be...
Yeah, even though that's what I normally listen to as well.
Yes,
but 4x, I'll be fine.
I'll put it on regular x for the sake of the audience.
Yes. I unfortunately cannot hear this.
You cannot hear this?
Oh, no.
Shoot.
The technical wonders of live streaming, of course.
All right.
Something was always going to go wrong.
All right, we're back. I figured out how to have the audio in the recording. Here we go. Sorry. Thanks everyone for your patience.
Begin by sort of spelling that out, what your worldview is in that sense.
Well, you mentioned when you say my worldview, you mentioned the three worlds, which I often use to describe. Like these are things also, the three mysteries, if you like. Well, one of these, you say there's the physical world, things like tables and so on, and what we think of as the physical world, although it's not quite clear when we go deeply into what's going on, what that really means, but never mind about that. The physical world, and then there's the mental world, that's our experiences, consciousness, feelings about things, so on. And then there's what you call the abstract world. I would be more specific about that. It's a mathematical abstraction. So we're thinking about how it is that... Well, let me secondly explain the mysteries, you see.
Go ahead.
Mystery number one is the fact that this world of physics seems to depend so extraordinarily precisely, and the more we explore it, the more precise we see this is. It's so precisely guided by mathematical equations. So we have these mathematical, let's not just say equations, that's a bit too specific, mathematical principles, which govern in such a precise way the way this physical world operates. And there is, if you like, a huge mystery. I'm calling it a mystery. These things, we're never quite sure whether...
is this what Eugene Wigner famously spoke as the unreasonable effectiveness of mathematics? It just seems to be an extraordinarily remarkable fact that mathematics, that the universe seems to be written in that language, and that we can discover it.
That's exactly it, yes. Yes. And the more we know about how things operate, I mean, now there's such extraordinary precision there are in measurements. Well, Einstein's general relativity is very, very precisely determined, and laws of quantum mechanics and how they interrelate with, well, even with gravity in some respects. I mean, how clocks. One of the Einstein's predictions is that a clock up high will run more slowly than one down here, and this precision in that. I'm sorry, I got it the wrong way around.
But I know what you mean. Yes,
that,
the precision
is
extraordinary. Yeah.
But the precision, even from down here to maybe a centimeter above, and they can measure the difference.
Yes.
So these are extraordinarily precise. Now, okay, it just shows that the mathematical theories, when we really understand them and when we get them right, they're still not quite right. That's clear. But nevertheless, the precision is extraordinary. So that's mystery number one. Mystery number two is, how is it that conscious experience can arise when the circumstances seem to be right? Now, it doesn't seem to be probably, I'm just guessing, but I don't think it's present in that glass or in the water in the glass. But nevertheless, it seems to come about certainly with human beings, and I think with other animals. I don't think it's unique to human beings.
Certain brain structures somehow seem to give rise to to this consciousness.
And there is a genuine mystery, I think, and it's not just a matter of complicated computations. There's something much more subtle going on. So that's mystery number two, and mystery number three is our ability to use our conscious understanding to comprehend mathematics and these very extraordinary and self-consistent but deep ideas which are very far from our experiences. So that's how we comprehend mathematics, if you like.
And in that sense, you believe that mathematics, for instance, is discovered rather than invented by us. In that sense, it exists independently of us.
Right. Yes.
And one of those great mysteries, as you say, is the fact that we can access it. Seems itself a remarkable feat of reality.
That's right, because it's so indirectly connected with our existence and what how we get along in the world, and how natural selection has helped us to survive and so on. It's really hard to see how these things come about from that.
There's three big mysteries there to kick us off with. Bill, what's your response to some of these?
Right, I'll stop it there.
Yeah.
So, three worlds, three mysteries. There's the physical world, the mental world, and the mathematical world.
Yes.
And then the mysteries are essentially the relationship between the worlds. Mystery one, why is the physical world so well governed by mathematics? Mystery two, what do our minds have to do with the physical universe? Then mystery number three, what do our minds have to do with the abstract universe? Basically, right? You could do a triangle.
Yeah, it's a triangle. There's only three sides to a triangle. So yeah, you got 3 points. There you go. That's the entire graph drawn. Yeah. So yeah, it's an interesting question. It's a very common one as well, because if you look at it from different points of view in general, like that's how you'd break many things down. Yes, you could add some more to it, but in general, if you opened the mathematical aspect up and probably just said it's more abstract things, or at least other just properties of things, then it's probably, that covers everything. So in there, you could probably put also like the aesthetic attributes or the moral attributes or any like generally those abstract objects that aren't necessarily mathematics related. So yeah, you've now got three things. And it's very interesting, like what are the connections and why is there connections? And I know what William Lane Craig is now going to go on to next, which we could probably summarize or we could watch the video either way. And he's trying to say, okay, he is trying to find a way of like, okay, which one of these could we try and find a unifying principle to do? And which one of the three could be the unifier? That's what Craig is kind of going there for. And he just rules out the physical world, it rules out the mathematical world, so therefore it must be probably in the mind world. And then Roger Penrose does eventually later on kind of go, what if it's none of them? Why assume it has to be one of them? Like it could be any of them, it could be something more fundamental. Like why does it have to be built into one of them?
Right.
And that's kind of like, again, the gist of kind of my criticism with Craig there. But it is very interesting. Like they are, I would say, yes, they are the mysteries. They are the mysteries. They are weird mysteries as well. I don't know about you.
Right. Well, I mean, because it's weird. It would be weird if our minds were just purely physical,
Yeah.
right? If we just say, if we go down for mystery, what's the relationship between mind and the world? If we just say that's a false mystery, right? Our minds are just part of the physical world, etc. Then it still leaves open the mystery of, okay, so why can we think about the laws of mathematics and physics and then observe that they're in the world, right? Like how could our minds, if they're simply a facet of the physical world, how could they think about something that's true of the whole world without being the whole world, right? Couldn't our minds only think about particular things or something like that, right? Like if our minds are just a small thing in the big thing, how could we think about something that is bigger than the big thing? And I don't know if that makes
well, the
any
easiest
sense
argument to
as an
say is that we're
argument.
not thinking about the big thing. We're just making a model of the big thing, aren't we? And we're making different
Yeah.
models, and that's kind of like brains work. And even animals' brains, they just make assumptions, they make heuristics, intuition, like instincts, I should say, not intuitions. Just generally things they've built over kind of evolutionary processes that have been worked for survival. And I can do the naturalist spiel quite easily, very easily, in fact. And the thing is that you can do that kind of thing, but then it gets you into two problems. You get either, as you were speaking in a previous video when you were talking about John Vervaeke and Paul van der Klee, which is the argument from reason problem, or the evolutionary argument against naturalism. They are effectively the same kind of argument, just tweaked ever so slightly here or there. The argument for reasons from C.S. Lewis, the other one's from Plantinga. There's also one from Victor Reppert as well, and so on and so forth. The other argument isn't necessarily an argument from reason. It's more of a... I'm trying to think of the right word for this. It's more of a... It is a question of reason in general, but it's not the same as you're trying to reduce things down to the physical always. And the question is, why are you making that assumption in the first place? So you've got this kind of a weird assumption that you're already making, if that makes any sense. So it's kind of a... probably contradictory things, like performative contradictory, and it's like, the other one is I know what it was, the Kripke problem. If you know the quaddition problem, like how do you know you're actually doing addition and not doing something called quaddition, for people who've never heard? So the idea that Kripke's a famous philosopher. Kripke's point is like, okay, quaddition looks like addition, but it's slightly different. What happens is everything works like addition, except if you get the two numbers, either one is greater than like 10, the numbers a plus b all equals 57. Like, how do you know that's not the case? And then just replace 57 with a bigger number until it gets to the biggest number you've never thought of. How do you not do that? The thing is, many animals probably do that from evolution. They're not really doing actual addition, but we know we are doing addition. So why we know we're doing it? It's a very weird question.
It's similar to the Chinese room sort of thing, right?
Similar, yes.
Yeah. And how do we know that it's not just an operation at which we don't comprehend? It's sort of the doing a mental operation and understanding what you're doing while you're doing the mental operation question. Yeah. So I mean, I think first off, I should say I like Roger Penrose's clear elucidation of a good question, right? A lot of good philosophy and good thinking is posing a good question and articulating it clearly. And I think that does make sense. I know that some people might, go down the road of, well, it's got this weird Cartesian mind world dualism. Yep. And I think it kind of does, but, like I would say actually that Cartesian dualism is really sort of more like a attempt to explain this problem.
Yeah. I have the book. It's a very good book. Look, there you go. There's the front cover. There's the back cover. Yeah, it's a very interesting question to problem, because it is the question like Descartes was trying to solve an interesting question, and most people get him wrong, like really wrong, because they're usually misunderstanding what people view him as. So if you actually just read him, he's trying to solve the problem of, well, are physical properties and can mental properties be reducible physical properties or not? And if not, what these properties must have like a substrate they come from. So therefore, there's two substances, a physical substance and a mental substance. That's all he's trying to solve. Yeah. He's not doing anything about the soul or anything like that necessarily. It's just the intellect and the body. That's it. And it's a very interesting problem. I don't know if I agree with it or not. It's one of those where I'm actually quite ambivalent on this. So, But it's an interesting problem, and it is interesting. Right? It's like there is this dualist split. It's like there's a difference between your mind and your body. You're right, and it's the question is why and how do they interact? Which is also the problem Descartes tried to do, and he got it. It was just bad. His explanation was really bad. Like,
yeah, Descartes for whatever reason has fallen on hard times. He's not very
Yes.
popular at the moment.
no, he's not for some reason.
I suppose that's the fate of all important philosophers, is that they will suffer the fate of being so influential that their intellectual descendants will eventually get mad at them for their shortcomings.
Yeah. I mean, he was a man. He was a very smart man. But like, I mean, there's many smart philosophers out there, and most of them, everyone probably disagrees with a lot of them anyway. But it's like, just everyone's got their complaints, I guess, and there's certain philosophers everyone hates. I've got very specific ones which I won't say because I know I'll offend some people.
If it's Augustine, you won't offend me if you don't like Augustine.
No, I quite like Augustine. He's quite spicy when he's kind of like criticizing other people, if you know what I mean.
Yeah.
Which is great. He's like, oh, there's spice in there. But no.
All right. Let's listen to William Lane Craig's response to the three problems, or the three mysteries, or the three worlds.
It's huge.
Well, I want to say first and foremost that one of the most exciting things about Roger's thinking is this deep metaphysical vision of reality that he has. It's in such contrast to the sort of positivistic and verificationistic pronouncements of many scientists who think that philosophy is dead and that these metaphysical questions are meaningless. Roger is engaged in questions that are not simply physical or scientific. These are meta-physical questions. And I think that the fundamental issue that is raised by this tripartite metaphysics is the ancient philosophical problem of the one and the many. That is to say, what is the underlying unity of these three seemingly disparate realms of reality: the mental, the abstract, and the physical. These realms of reality are so different, so causally unconnected, it seems, that one wonders what is the underlying unity for all of these. So how are these three realms related? For example, the mathematical abstract realm cannot be the source of the physical or conscious mental realm, because abstract objects by definition are causally effete. That's part of what it means to be an abstract object. The number 7, for example, has no effect upon anything. So the abstract realm cannot provide the source of unity. Could it be the physical realm that provides the source? Well, Roger's already mentioned the second mystery. How does the physical give rise to consciousness, particularly intentionality? The intentionality is the aboutness of our mental states. I can think about my summer vacation. No physical object has intentionality. So the mental is difficult to derive from the physical, and the abstract, it seems to me, is impossible, because the mathematical realm is characterized by necessity. These are logically necessary truths, and by its plenitude. There are infinite realms of mathematical objects. And the physical realm, by contrast, is contingent, and therefore cannot ground these logical and mathematical truths, and it's plausibly finite as well. So the physical can't be the support. Now, what about the mental? Could the mental be the source of these other two realms? Well, in mental causation, we do have the experience of the mental causing physical changes in our brain. I can will to get up or to speak. Similarly, many philosophers have thought that the abstract realm is not really a separate realm that exists by itself, but they are ideas in the mind of consciousness, that they are the result of intellection by a mind. Now, the problem is that no human mind could be the source of the abstract realm, because of its plenitude and necessity, whereas we are contingent and finite. So what I want to invite Roger to comment on is, why couldn't the mental realm include an infinite consciousness? That is to say, an omniscient mind which has created the physical realm and which is the source of the abstract mathematical realm. This would solve the problem of the one and the many and give you an underlying unity for this tripartite metaphysic that you affirm.
And what you've
on William Lane Craig's response, there's a lot of what he says that's good, but there's a lot of what he says that I'm not sure is quite good. The physical realm is contingent, right? The abstract realm is full of necessity, and the mental. So basically, what I think is interesting is in like classical Neoplatonism, the way that Plotinus would have solved this problem is that we have the one, which is above all of these three things, right? And it is basically impossible to talk about it because you have to use categories to talk, but the categories are rooted in the one. So you can't like use something that's below it to talk about something that's above it, right? So you have this thing that is virtually indescribable. You can only really describe it negatively. You can think about it more or less correctly, but you should always have a hedge of caution, right, in what you say about the one. But it's the source of everything. And then from the one then comes what in this discussion would be the realm of eternal mathematics. What's interesting is he would put the eternal realm, the eternal truth realm, nous is what he would call it, or mind, but actually really I think it corresponds to the mathematical realm as Penrose is describing it. Because it's unchanging, it's eternally true, right? So that's why it is closest to the one, is because it doesn't change, and that's a good thing in Neoplatonism, right? So it's the most like the one because it's always true and unchanging. And then comes like what in Neoplatonism is called the soul, but that would be like the conscious realm as Penrose has labeled it, right? And then there's like one big giant soul, and then there's sort of the physical world, and we each have souls that are somehow reminiscent of the big world soul, but souls can move up and contemplate the eternal realm, right? And so that is, and then it's unclear exactly what Plotinus thinks matter is. Is it something that is a fourth emanation, or is it something that at the end of the day doesn't have real existence and is only kind of pretend? Plotinus struggles with a good, clear definition of matter, but he stacks them basically, right? And he stacks them in a different order than William Lane Craig seems to want to stack them. And then Plotinus also has the one which is above them, and William Lane Craig isn't seemingly going down that route.
Like what something in here, I can't remember if in this particular section or in just general, like Craig was criticizing like severness. That doesn't really, that's as inert, that doesn't, you don't have anything, it doesn't really have any force in the world. Well, I would say it's quite the opposite. Severness has a lot of strength in the world. Like you have numbers, like these mathematical things have power in the world. They even participate in the world. They embody things and such. So to say that they don't is kind of like missing, like it's too obvious. It's like you're missing the point. You're missing the obvious thing. Like, no, they really have so much control over the world. Apparently, we just take it for granted.
Apparently this is a common definition in analytic philosophy at the moment. Really, I only know about analytic philosophy because I listen to analytic philosophers argue about the Trinity. But basically an abstract thing is something, it is defined as abstract precisely because it cannot cause anything. And that's like the definition of abstract.
Yeah, I can understand when it says it doesn't cause, but you get different fudge words of causation as well. Really, it's a really fudgy word. And it's like even different types of causation, and then you split it down. So when you do that, it gets a bit like, it doesn't cause anything, but it kind of, that's why I didn't try to use the word cause in here like what he would do. I would say, no, it does have control, it has power, it has influence, because there's certain properties, which is kind of related to like physics is very much mathematical. Before well, even in Aristotle was kind of doing like basic mathematical equations as such, and his stuff was not bad. This is probably a contentious thing anyway. His stuff at the time was not that bad. For his experiments and such, he wasn't that far off. Like, for instance, he thought the fluids in I think balls flowing through fluids would were their velocity was proportional to their mass, I think, or something like that, which is wrong. But it wasn't a bad explanation. Like, if at the time,
but it's at least in the realm of he's using ontology
Mathematics.
and formulas.
Yeah, which
to
is really weird. And
physics,
then
right?
I think there's some other philosophers like 100 years later corrected them and actually got even better. So like people forget that. And then it wasn't until really you get to about Newton that it's like completely mathematical, like completely. And like, okay, you've now got the three laws. It's F equals ma is the second law as well. Like, okay, this force equals mass times acceleration, or technically it's the rate of change of momentum equals force, but whatever. And then because you can explain all the laws of motion with these equations, and also you can do gravity with mathematics as well. It's like these are really good ways of extreme things, like with laws of and using mathematics. It is such a weird thing, and I agree with Penrose on this. Like, why is it so good? And not just that, it doesn't stop. Every time you get more leaps in physics, like we get to quantum mechanics or general relativity, it's like it's more and more advanced.
The precision
mathematics.
increases
and the precision increases. Like when he's talking about clocks, like I used to do that for a living. That was my area. I used to do condensed matter physics, like quantum clocks, and the precision on those things is 10 to the minus 19. So that's probably not very useful. But like that's a 0 point and then 18 zeros and a 1. Like that's how the relative accuracy, precision of these things you can get, and even higher sometimes are probably getting. Like these are stupidly precise, and you're able to measure things. And they're not just that. Like even like GPS relies upon this as well. Like we need to know that general relativity and special relativity work this way. So the clocks. So there's actually two counteracting forces here. So it's actually a bit weird. So the closer you are to the Earth, your clocks will go slower. Yeah. Because you're more closer to a gravitational body. So the further away, your clocks will go faster. But if you're moving very fast, your clocks will go slow. Yeah. So it turns out the clocks in the sky actually tick slower than on the ground.
Because of their
they're going
velocity?
that fast.
Yeah.
They're going that fast. So you'd think they would go faster because they're further away from the Earth, but actually because they're going so much faster, they actually have to tick slower. So they have to take that into account when they're making the GPS satellites.
Right.
And it's like, whoa.
And isn't it true, like, if an astronaut wears a super precise watch, goes up to the International Space Station for a while, and comes back, their watch will be slightly off,
Yeah, there'll be a few
Houston
seconds out,
time.
Yeah. It is insane, but it's like that's how it works and predicted, and we know, and it's heavily tested. Like general relativity is one of the most heavily tested things ever, and it's highly precise. And there's also like quantum field theory, which is the quantum mechanics thing. That's extremely precise as well. But it's bizarre that this mathematics that you can describe the world and do it to that amount of precision.
So I guess one of the Sir Roger mysteries is, so what gives the equations fire, right?
Yeah.
Because like the Plotinus point would be like, well, those equations aren't changing, they aren't moving, they're static. And William Lane Craig would even say they seem sort of inert, right?
Yes.
And so why is the world seemingly in motion and active and animate in a way that conforms to these laws? Like where's the fire come from? How does, who pressed go and like, what does go even mean?
It is one of those things where like usually like this is what I find in people in general when you talk about like their philosophical views, they usually fall into two camps. Usually I'm making it very broad sweeps here, but they always keep asking the why question, or they just say, well, that's just how it is. What are you talking about? Like, and what I mean, well, the reason why I bring this up because like Roger Penrose is a scientist and he keeps asking that why question, but he's also asking the why as in like, what's the cause of this? What's the reason behind this? Not just like, oh, what was X for this? And it's just like an accidental series. But then many people say, like, why do you need to ask that? That's just how the world is. Why are you asking those silly questions? That's just how it works. And many people do think that way as well. Even some scientists, surprisingly. And then, but you can see that's where Roger Penrose is going. And weirdly enough, and Craig in this argument is kind of like, well, that explains everything. And Craig's like, and then Penrose is like, what does it explain? It doesn't explain anything. What are you talking about? And it's because for Penrose, that isn't a useful enough. It isn't useful. Like, okay, this is an explanation. What use of it is that to me?
Yeah.
And that's very much a clearly like pragmatic view.
There's a little bit of positive positivism, right? At
Yeah.
the beginning, William Lane Craig complimented Sir Roger for not being
Yeah.
too positivistic, but it still seems like he is kind of positivistic.
Which is not necessarily a bad thing. I would say that's a good thing in a physicist, because you need to make sure your ideas correlate with reality, and you can test them, obviously, because if you can't test, if they're not falsifiable, then it's not really science what you're doing to a certain extent.
Well, it's interesting. One of the answers, William, I'm not sure if we'll play that section. Maybe we will, maybe we won't. But one of the answers that William Lane Craig gives is like, well, in addition to being a story, and I think part of it is that Sir Rogers is like, that's like a just so story, right? It's a post facto nice description that verbally accounts for the questions that I'm talking about, but without seemingly giving any oomph as a result of the answer. I think is sort of what he means. But then one of the things, I thought the only clear answer to that question, to that objection from Roger, that William will give is that it can include morality now too.
Yes.
And that is something that seemingly you can't do without some of these answers.
No, and like you can't get morality from the physical problem, because you're going to get a naturalistic fallacy. That's a G-Moore statement. That means a very technical thing. You can't bridge the Isort gap. You can't get. It could say maybe it's the mathematical, but then you're just saying they are inert. And I agree with Craig in this regard. They're just inert. There's no oughtness to them anymore. They're just abstract descriptions. There's no prescription to it. So yeah, there has to be some other realm, effectively, where this morality comes from, the goodness aspect. And in the Neoplatonic or just monotheistic in general, like monotheism usually goes, well, it's God, it's God, and the goodness is godness. They're one and equal, and it's like, okay, but even then, that's still like, it's still you have to manifest it as a certain aspect. Like again, the mathematics is another one, and you got these. If you're doing the tiered approach, which is not a bad way of thinking about it, in my opinion. It does mean it's kind of a separate thing, and if you just have it as 3, three is still probably not enough. But it's I'm not going to criticize Penrose for that.
So I get Penrose's objection, but I also have some other kind of objections to William Lane Craig's answer. So William Lane Craig's answer, like Neoplatonism is like one abstract mathematical world, mind, physical world, right? In like a 4-part thing with absolute unity at the top and emanation down, or emanation down and emergence back up, right?
Yes.
Something like that. And William Lane Craig is doing something a little bit different. He's actually putting mind prior to the abstract truth, right?
Yeah.
And then it's funny, maybe he wasn't speaking super precisely, but he almost seemed to describe God as a mind within the mental world, which would be weird because then there would be something that's bigger than God, right?
Yeah, but he was very sloppy here, very sloppy. And not just that, he was pretty much it was very close to saying making an idealist argument, and I know he's not an idealist, but it's so close to making it, which was like, I know that would be bad for him. I'm not gonna. It doesn't make any difference to me.
I've talked
for instance, the ideas argument is like everything is a mental states. There's no real physical reality. It all derives from that, and not just, or if there is, it's just everything is part of the mind of God. So therefore, that's where mathematics comes from. That's where everyone else comes from. That's where everything comes from. It's just from the mind of God, and that does solve a lot of problems. I will admit, it does it does make things a lot easier. But yeah, as you say, it's like, well, there's mathematics, and it seems the mathematics also and logic seems to govern it as well. So like that can't be not necessarily derivative of it, because it seems like reason is very tied to logic as well.
Yeah,
there's a logic
it's
to
sort
it.
of
So
like,
you can't say the ordering's wrong, in my opinion.
Mind seems structured, right? And it doesn't seem like the sort of thing that produces structure.
Yes.
Right, and that's sort of what
it can structure things, but there's an already pre-existing structure to structure it.
Yes, and so that seems to be the problem of putting mind first. Is sort of like, well, what's the mind running on, right? It doesn't seem like mind's the thing that could run something else. It seems like mind is the thing that needs to be in something to be run. And that's part of, I think, the Neoplatonic reason for putting mind beneath eternal truth or structure or logos or whatever you want to call it.
Yeah, logos is, just say logos. That's literally, that
Logos,
covers
yeah.
all of mathematics effectively. Logos,
Right.
logic. Wait, there's the word logic.
Although Plotinus used nous, which is mind, which messes up the whole.
I know,
anyway,
and nous is not even technically mind. It's a bit weirder as well. And
yeah.
oh,
so logos works better in English.
Yes, it does.
So that and it did kind of seem like William Lane Craig almost imagined God as just like the super mind within the mental realm that generates perhaps the other minds or something within it.
Yeah, I would probably mean he's probably going to say no. It is the mental realm,
right?
And it is the super mind. It's like the meta. It's super not as in big, but super as in above. I'm just trying to defend his position here. So, but in that sense, he's, in my opinion, that's just saying idealism.
Yes,
and that's a very and I know he's not an idealist, but he's just made an argument for it.
Yeah. I talked with Keith Ward, who is a Anglican philosopher, and he's like a self-described idealist. And he seems to make a little bit more sense on this subject than William Lane Craig, because it does seem like William Lane Craig is going to have a hard time avoiding idealism down this route. And in fact, I just don't even know what his alternative is and what it would even be called.
I think Craig in this argument, I say argument, just kind of discussion, he was trying his best to try and like evangelize in a sense, in a weird sense. And I think that's where he kind of follows. Oh, I'll try and get him here. But it's like, well, you're just undermine your own position, like completely. So just don't do that, Craig. Just don't do it. And yeah, that's why I was kind of like, I know your own position. It's not this one. Why are you going down this track? And it's not going to convince anyone. It's definitely not going to convince Penrose in one sitting.
Yeah.
But yeah, so it was kind of an interesting discussion. They do go on to other things, obviously, so that's the main topic, and it's interesting mysteries, because I know Penrose has, and he does not talk about this in this video, if I remember correctly. But Penrose has his pet hypothesis, and he wants to test it against specific like structures in the brain, like, okay, how does consciousness kind of like retain itself? Like, okay, you can knocked out and then you come back again, and like what happens and why does it persist? And he's looking at certain, I think, microtubules in the cells of the brain, and that's his kind of like pet project. I'm not saying I agree with it or anything. I'm not sure what problem he's actually trying to solve with it, to be honest with you. He thinks
he basically is.
It sounds like a memory problem.
He's basically saying that I think he's trying to say that consciousness emerges from the physical biological makeup of brains.
Which is not, or at least
point
standpoint,
to the bridge.
Fine.
Yeah.
But it's one of those where it's still, what he's describing is not what he's saying. Like, he's effectively saying, like, we need some way of storing state, and it just needs to be persistent and very rigid, and it doesn't decay easily. And it's like, okay, but then it's weird. Like, I know his pet project, and to me, it doesn't make much sense what he's trying to achieve. Like, even if it's correct, it doesn't really explain anything. In my opinion, which is kind of ironic for him. He's trying to explain stuff, and I'm like, it doesn't really explain anything.
Yeah. He likes explainability with oomph behind it.
Yeah.
And it doesn't seem like that. Yeah, I've heard him talk about that consciousness thing too. Yeah.
Yeah. But again, he doesn't talk about it in this video, so I won't talk about it anymore. Easy enough.
Because so far, I guess so far it seems like Sir Roger Penrose basically has a triangle, right?
Yes.
With arrows in either direction that are hard to understand. But it is not a hierarchy. It is if it's a trinity, it's an egalitarian trinity.
Yes, right? They're all on their own level. Yes.
Yes. And
if not on their own level, I would say you'd put mathematics above physical, probably, because it's kind of like governing a system.
Yeah.
But that's about it. Like, it's still only slightly above. So it's very flat.
And when he talks about there being microtubules in the brain that give rise to consciousness, that would seem to suggest that he leans towards putting the conscious realm beneath the physical.
Yes.
As if it would go abstract truth, physical, consciousness, but then consciousness has this weird background to get back up to the eternal truth.
It depends on that way. We're just doing the Platonic way of doing it, but if we do it a different way, like, or traditional, like the consciousness or mind in general is an emergent property of the physical thing. So he's technically being a physicalist in a sense, even if it's non-naturalist. a non-reductivist, sorry, non-reductive physicalist argument. But then he's going, but the mathematics is above, so it's emanating down and controlling the structure. It's a weird thing. So it's kind of like it is a union of the two, but then it's this weird thing in the middle. It doesn't make any sense. So that's his intuitions, and he clearly is expressing them. He may not understand that, but he's expressing it. People do that all the time, obviously, don't they? But yeah, I do it all the time as well.
One thing I just thought of with Williams' model, which is basically mind, eternal truth, matter, is that it would also make sense why he wants to go down the route of a fine-tuning argument, because that would be the structure of the ordering of the three mysteries if fine-tuning makes sense, right? Because
so
the mind,
I actually hate the fine-tune argument. I think it's literally nonsense.
I actually don't like it either, but
no. They all keep doing this, but every person who likes this does the exact same mistake, the exact same one. They assume that these parameters could be different.
Yeah.
So they make it so it's highly unlikely this is the case. I'm like, how do you know it's highly unlikely? So if this is a statistical thing, why do we only have one data point? So how can we make any model from that? Yeah. Literally any model. It doesn't matter if you're using frequentist or Bayesian approaches. Right. What statistical model are you producing to get this highly unlikely thing from? So that's the first problem.
Statistics needs at least two. If we're doing one, we're not doing statistics.
Exactly. Two. You need two, but we only have one. We only have one universe, so that's the first thing. Secondly, you're assuming these constants of the universe for the fine-tune modeling, they could be different. Like, what if they have to be metaphysically necessary to be that? You have no idea. You don't know any other way. So all of this is extreme speculation, and they're using, this is a proof, it's a very good argument. I'm like, well, your foundations are already wrong. Like, they're so flaky, but it's very rare you'll see people criticizing this way, and I'm like, but that's the obvious way. Like, if you're going to do a statistical argument, at least have two data points, please. Oh, wait, we can only have one. Damn it. And that's why I really hate the argument. He was trying his best to use it, and he was trying to do it. And there are different approaches, like even solutions to the fine-tuning argument. I know one that Stephen Hawking did back in the day. He was saying like, oh, all of these constants are in a superposition with all the other ones. And the only reason we observe is the way we have is that all the other possible histories got eliminated, and it was just collapsed into the current way we have got. So it's a very quantum mechanical approach, and that's why you would see it this way. So it's not an anthropic approach anymore. It's more of a kind of consistent histories approach. Like the histories have to be consistent, and that's with the waveform and how it works. I'm like, I don't agree with that one either, but I'm like, it's still like you're agreeing with the premises that it's fine-tuning, which makes like you don't even know that. You can't even know that ontologically speaking.
Should we listen to the fine-tuning part? Because
I'd love to, but people already got the spoilers of what I already just.
Well, sometimes it helps. Annoys me. Sometimes it helps to give a preview, and then it helps what they say make more sense, and then we can expand on it. So I'm going to skip ahead to the fine-tuning section. It's a little bit long. I might stop before they finish the whole thing. We'll see, because it's 14 minutes, the whole thing. Well, I'll start it right at the beginning, and either you can wave me to stop, or I'll decide at some point.
No, that's fine. I'll interrupt. Don't worry.
All right. Yeah, just speak up. All right.
Some point. This is often called the fine-tuning of the universe for life. Bill, do you want to very briefly explain from your perspective why you see this as an interesting argument for the existence of God?
Well, in the contemporary literature on fine-tuning, there are basically three explanatory options. Either physical necessity, that these constants and quantities must have the values they do, that it's not contingent, or secondly, chance. And the form that this normally takes would be a kind of multiverse hypothesis, and then an appeal to an observer selection, self-selection effect, that we can only observe universes that are finely tuned for our existence. So we shouldn't be surprised that somewhere in the infinite multiverse that we should appear in such a universe. And then the third one would be design, that there is an intelligence that has designed the universe. And Roger's a special contribution, I think, to this has been to place a very significant objection and question mark behind the explanation of the multiverse hypothesis, with the self-selection effect, because if we were just a random member of a multiverse, we ought to be observing a much different universe than we do.
I want to come to that. I mean,
what?
On this question of fine-tuning, which again, we might be...
Sorry, I'm like, how can he make that claim? Like, yes, we have to be... We'd obviously see it different. I'm like, how would you know this question, Craig? Come on, tell me. Sorry, it's these things, like assertions, that would kind of frustrate me. Like, why would you expect to see another universe? It's more likely. I'm like, because the other ones are more likely. I'm like, what? That's like saying I rolled a die and I was like, I got a 3. Well, I was more likely to get all the other numbers. Why didn't I see the other numbers? It's like, because you rolled a 3. Sorry, it's just one of those.
Here's my argument. So the Bill, or I'll call William Lane Craig William, and I'll call you Bill.
That's fine.
Just to keep things clear. So William kind of laid out the fine tuning argument. It's like, hey, there are these parts of our physical ontology called constants that just seem like brute facts. The relationship between that they're inside the equations, but they're not part of the structure of the equations. They're just like a factor in the equation that just is what it is, with seemingly no answer behind it, right? It's just, well, this is the constant, the gravitational
This is a brute
constant.
fact, yeah. Anscombe, yeah, I hate her for that. Well, I don't hate her for that, but she came up with the term at least anyway. But it's one of those, yeah, and it's weird, like the like these are, in a sense, they could be brute facts. That's the best way of putting it. Or some of them are brute facts, and then the other derive from it. But many things are brute facts. If you're going to say like, moral properties, they are because they are that way. It's like just because it just is. It's that just isness, as I was saying earlier. Not like there's a reason why, and it keeps going.
And what's interesting about the constants is it's not like they're equations that seem logically necessary. They are aspects of the equation that aren't themselves defined by the equation, right? And I guess I'm trying,
they are very, if you have like an equation, like if you learn from school, like for people listening, like it could be a times b plus 1, where a and b have to be determined through an experiment. Like it's very simple like that. And these are not like, this is the equation, how the equation works, but we need to figure out what those numbers are. Well, I'm just
right. It's like an exchange rate almost, right? Like if I'm converting dollars to euros, right? Okay, so the equal sign means that I have to go from dollars to euros, but the exchange rate is, what varies from day to day, right? But that's sort of the thing. There's structure, and then there is sort of seemingly this almost arbitrariness inside the structure. And so it's like, is that arbitrariness something that God decided such that it would shape the universe in such a way that, and so here's my problem with the argument, with the fine-tuning argument. It's like, I think it makes sense in William's structure where he has mind, eternal truth, matter, right? Because the mind is figuring out what it should have the eternal truths be, such that matter turns out the way the mind wants, right? That's basically right. Which does at least somewhat make sense.
No, it makes sense. No, I agree.
I'll
go with that.
But here's my problem is it's sort of like the analogy to us is like, when video game designers design video games, right? If they're designing the newest Halo video game, they can't have one of the guns be too powerful, right, compared to the other guns. All the guns have to have strengths and weaknesses, or else everyone would just use the one best gun.
Say it's OP. It's OP. What are you talking about?
Yeah, right.
Nerf it now. Nerf it. For people who don't know that terminology.
Right. So the video game designers are messing with the powerfulness of the guns, which are basically parameters in the computer code of how much damage they do, such that it's a balanced game, and then they have the purpose of it being a balanced game. And the NFL football commissioners are always meddling with the overtime rules, such that it's a fun game to watch and isn't too arbitrarily defined by a coin flip, because it's not fun to watch that the outcome of a tied football game is 70% determined by the coin flip. It should only be like 20% determined by the coin flip, right? So they're meddling with the rules because they have purposes in their mind that they want want to achieve,
Yes.
right? And they have controls over some of these parameters that gives them degrees of freedom to shape the game. And so, right, like that's sort of the analogy. But to me, like when we're designing games, right, we're already controlled by the structure.
Yes.
Right. The game itself is embedded in the physical structure and is sort of like a microcosm, right? Like a football game is a microcosm of the whole world. A video game is like a microcosm of the whole world, but there are already underlying structures that give it shape. And to me, it's sort of like putting God in this weird place as someone who's trying to solve a puzzle that he built for himself, right? In a way that just doesn't quite seem theologically befitting. And I would also say that, like, it's kind of presumptuous about God's purposes in a way that strikes me in a way.
I was about to say, I was bringing up the other thing is this entire thing seems very hubristic to me. Like it's the same arguments, like the atheist arguments will say, like the problem of evil. Like, well, I can imagine a better world without X, which is bad. Well, if I can, then why couldn't God design a universe that way? So there's two hubristic arguments. The first one is one you think you can be better than God, but that's not the big one. Actually, I think that's the tiny one. The big one is you can think of designing a universe. That's the big problem.
Yeah.
You think you could design a universe? Oh, that's the thing that really annoys me about people who made that argument, because they realize they don't actually know what they've just said.
Yeah.
And
we can design games. That is true.
Yes.
Yeah.
Yes, and they always probably have bugs in them as well. And it's not just because the hardware's buggy, like the software's buggy. I mean, I do software all day as well with my physics. Like I do fluid sims. There you go. And I've got loads of books on my desk if you didn't guess. But it's one of those where it's like, look, like when you're doing games, okay, you're programming in a programming language. And even if you created that language, like I've created my own language, usually you're still governed by certain laws and axioms of your logic. Like you are you got a type system. This is the technical stuff, but you got logic effectively. It's certain logic and certain axioms you're paying up. But the thing is, the axioms you've just set are still kind of governed by something to make it even work in the first place.
Yes.
So even though you've chosen certain rules, those rules, how they would even work, it's like that already exists somewhere else, and there's only certain rules that would work anyway. So there's something governing, like something I say, like, but there's a governing aspect to it. And as soon as you realize that, it's like you've got it backwards, and it's not necessarily backwards. It's like they may be even on the same level of each other, kind of. But like they're not. One doesn't go. The mathematics stuff is clearly not below the mind.
And that relates back to one of my criticisms earlier of William, is that he seemed to place God as an agentival actor in a pre-existing mental system.
Yeah.
Right. And that also seems like a problem of the fine-tuning argument, is that God has these constraints that come from who knows where, right? That God is himself trying to turn the dials of the physical constants such that he gets what he wants out of it. But why in the world is he constrained already? Like
there could be certain things where, like, I'm just going to try and play devil's advocate here. Like, oh, he's constrained anyway because this is the problem, is you start going back to a Platonist, like Neoplatonistic argument, like saying, no, that God and his creation are one and the same. Like like mathematics is him, so therefore he cannot do anything different from that thing in itself. So therefore it would be contradictory to be anything else. So he's very simple in that regard, saying like, well, godness is goodness, godness is mathematics, godness, good, all the same thing.
Mm-hmm.
So, being the very classical theistic view, that's the way you'd get around that problem. Like, he didn't choose, because that's the wrong word. It is him.
Yeah.
So it's kind of the oddity. But the weird thing is that there's this oddity of, like, there is the real world, there is Earth, there is the physical world, which is not necessary. God is not necessary in God. So God clearly did choose to do this and chose to do something else. So maybe this is where these questions start making not necessarily no sense, is that they are so complicated. Our brains can't understand it. It's the best way of putting it. And our minds can't understand it.
Yeah.
I'm doing both there, because clearly.
And I guess where the the fine-tuning argument has a little bit of a point is because the laws of physics themselves might be part of this necessarily true thing if, that just emerges from coherence itself or, trueness itself, but that the constants that don't seemingly have any explanation because they seem arbitrary, this does seem like a place where God could have freedom.
Yeah, and just play with that idea anyway. It's like, look, some arguments like, if gravity was a bit stronger, then you wouldn't be having many of the formations seen in the galaxy assuming the same laws. That you plug in the equations, change the number slightly, different things happen. And some things, that's what they're arguing. This is what people do the fine tuning. Like, if I just change this number slightly differently, we get completely different results. Some things aren't even stable. And like, okay, I'm not disagreeing with that, but my point is like, what if you don't? First off, that is also why can you actually change that? Maybe that has to be that number, and there's no other reason why cannot be that. The other thing
But then we're
also
have to
these
learn
are constants.
Wouldn't we have to learn? Well, that's a good point, because there's Rupert Sheldrake, to make Luke Thompson super happy there. I mentioned Rupert Sheldrake. He will make points about the constants if they seemingly differ over time, and I've only heard that from him, and I'll just say I have a half a hair of skepticism.
I won't comment on that, but they don't seem to be differed over time at all. But the thing is that there are hypotheses that maybe, like even Dirac, Paul Dirac, famous physicist, his view was like, for instance, maybe the gravitational constant is inversely proportional to time. So back in the past, it was stronger than it is today. Like, but there's no, and he was doing it for certain models and trying to make ideas and such, but like, there's no reasons why these have to be constant. We're just actually assuming them to be constant. It's very useful for us.
Mm-hmm.
And if they all vary at the same rate for some reason, then we wouldn't notice any difference to a certain degree. But for some reason, like they appear constant, so we're assuming that they're constant for all practical purposes.
So that's interesting that the constants themselves might only appear constant, but it's actually like a particularity of meassurement question.
Yeah.
Right. And you can't get around the
not just that, like
if
for people who don't know this, but the like units of measurement, like the meter, the SI units now, so meter, second, kilogram, all that, all of them have now been defined by the like constants, universal constants. And the way they do that is they set the universal constants to be a specific number in those units. So the speed of light is exactly, 299,792,458 meters per second. It's defined that way. That's how it's defined, that number precisely. So when you make measurements, you're now redefining, you're improving the measurement of the meter in the second.
They could only ever be measured to be constant, but that's how because of how
we've defined
measurement itself.
So hypothetically, what that just now means is our meter sticks or anything are just changing size if it wasn't constant. But that's the thing, is we have built into our measuring system, we're assuming these things are constant.
So
which I'm not saying they are. Most likely they are
warping. But every time we try and measure another warped meter stick by another warped meter stick, that's always 1 meter.
It's always like it is a weird thing, but it's like, let's see how they did it. And now and I understand why they've done it, defined it this way, because then you can do the experiment and you're in your own laboratory and then figure out what those measurements are. You don't have to go back to Paris and find out what the prototype for a meter or a kilogram is and measure your own thing against it. You could just build your own experiment, do this, and then you've got the right numbers. And then that's how you do it. So it's a better way of doing things, obviously. But again, it's always these metaphysical questions like, are these constants? Oh, are they not constant? Okay. Are these constants, could they have been, are they like necessarily have to be this value, or are they not necessarily this? Could there be anything else? It's like all these questions, I'm like, they're all unknown questions, maybe unknowable too. And like, you're making speculation saying this is a very good argument. This is why I don't like these fine-tuned arguments. There are much better arguments if you want to do for arguments for God. And these contingent ones, bad ones.
So this is a topic this will get slightly out of my physical depth, but one of the things that Sir Roger talks about is basically eternal recurrence, where he has multiple eons, where seemingly things collapse down to nothing, and then that nothing basically initiates a new Big Bang, and then things collapse down to something like, or nothing.
So it's nothing about
infinity,
actually.
or it's like,
so his cyclic conformal Cosmology, whatever we're calling it.
Mm.
So let's just do the basic standard one. So there's the Big Bang Cosmology. This is the idea that we looked into the space, and things seem to be getting further. The further away they are, the faster they're moving away from us. Which sounds a bit weird. Like, wait, the further they are, the faster they're moving away from us. And we can measure this with redshift. It's like, Doppler effect. So it's like if you hear like an ambulance and go nina, nina, and go and you can hear that. That's what redshift is. That applied to light. So that's stop sound for sound. For light, we'll do the same thing. So if you're going away, it goes redness. If it goes towards you, it goes blue. That's what happens. Things get shorter wavelengths. So when we measure this is Lemaitre, who was a Catholic priest, if I remember. He was the one to kind of notice this and discovered it, and then made the hypothesis that actually then there was actually a state in the universe where all of these, everything was kind of very like small, dense, and high compact to explain this. Because if you just train everything, it seems like everything compacts back together. So this point, this highly ordered point, small, like highly dense point, is what we call the Big Bang. Effectively, that's kind of singularity. And if we do look more measurements we've done in the past, this seems to be the case. Like the actual evidence points to like there is a point in the past which is highly dense, high entropy. Was high entropy or low entropy? I can never remember. No, low entropy.
Low entropy,
low
right?
entropy.
Because
so I always get
moved
mixed
from
up.
low to high.
I have to just remember what the second law is and go, oh, it's low entropy.
Yeah.
It's low entropy, highly ordered. Again, same thing. Very dense state, and it's like that's weird. So that's the standard comp view. Now, many people view that, okay, that means that's the beginning of time. And because the reason is, as soon as you try and go to that time at zero, when there is the pure the singularity, physics breaks down. So physics, all our things just tend to go to infinity. So literally just dividing by zero, effectively. That means like nothing works anymore. So there's no real understanding at the
and there's
point
no
of singularity.
Information in the physics sense of the word from before then.
Yeah. So it's like you can't measure it because it's kind of like, it literally is like a fire barrier, firewall of such.
No.
Because that's what it is. It's kind of like not necessarily a black hole, but it's like the equivalent of that in that sense. You've got a firewall going on. So that's the problem. So many people would say, even Stephen Hawking's position was this, that was the beginning of time itself, time and space. And there's no before that point. That doesn't make any sense. Some people, it's not as popular nowadays anymore. One is that there's a cycle. So you have a Big Bang and then it crunches back together and then it does no Big Bang. It's called the big crunch theory. So you've got a Big Bang and then a big crunch. So it's kind of a cyclic thing. So there's multiple of them. Another one, which is very popular nowadays, is eternal inflation. So there's actually, the universe we're in is just in a small packet, and all of a sudden it just expanded. But there could be other parts of the bigger universe, still universe, which then start expanding themselves. They have other Big Bangs going on eternally. So there's all these different parts that keep eternally
popcorn
big bangs.
mitosis.
Yes, that's the best way of putting it. Yeah, very good way of looking at it. Yeah. So it's like another thing, like it's just a universe is eternal, but there's just pockets where they do Big Bangs randomly. But notice all of these. There's either a beginning or it's just eternal. It's very interesting how in modern cosmology you get the ancient cosmology creeping back.
Yes, right.
It's like
it's so funny because like growing up in school and like this is one of the few things that science and church agreed with growing up, right? That there was a beginning and that there was really kind of one show and that this was it, right? But when you go back to like ancient Greece and stuff like that, there were all of these different things, right? There was kind of static or an eternal static universe, sort of like Aristotle. There was eternal recurrence, which the Stoics believed in.
Yeah.
And then there were the Epicureans who kind of had a random, undetermined universe with atoms crashing into each other and moving around at random and stuff like that. And what's interesting is like most people think that the Christian worldview was that there was creation ex nihilo that began at a certain point, and then it sort of culminates in the eschaton, and maybe the eschaton is like eternal time, or maybe it's like no time, but whatever. There's one show that has a beginning and then kind of an end, and then after the end is like eternal goodness or something like that, right? But but Origen, who is very influenced by the Neoplatonists, actually has finite recurrence. he was like, there are multiple worlds, but there was a first one and there will be a last one. So the Stoics are wrong about them being eternal, and also they're different from each other, right? The Stoics believed that you and I, Bill, have had this conversation an infinite number of times in the past, and we'll have it an infinite number of times in the future. It's just inevitable. This is just the way eons work.
Yep.
Whereas Origin had sort of like the eons get further away from God, and then Jesus comes and kind of reverses, at like the culmination of history, reverses the course, and then there's further eons that get back to God again, and that there's reincarnation of our souls. But in the beginning, we sort of made moral degress, and now we'll make moral progress as the result of the crucifixion or something like that.
Yeah, like, but the thing is, there's the point there. So there's a difference between like internal, it's like infinite, like time, and then finiteness. There's a beginning to it. So it still could be eternal, but like it's eternal in one direction, not in both directions.
Yeah.
But this is one thing in general, is like the finiteness, that there's a direction of time and not just its cycles, is pretty much, I can only see it in like monotheistic religions. So only the monotheistic ones have this conception. So it is a really fascinating one, because it also means that if as soon as you get into that mind frame, then you start think like, oh, there's causes to things. Like you start having this very particular way of looking at science. Not that there isn't, like clearly people in the past had science, they really did. You can just look at the technology they had. I'm like, yeah, they clearly had science. But what I mean is that now there's a different way of looking at things, and there's a reason for it. It's like a proper ordering to the world, and it's not just the same cycle over and over again, like a Stoic, or like a Nordic religion, where the Norse were like, it was just the thing sitting going over again, and it was like, oh, the end of the world is Ragnarok, and then they come back to the same era. In fact, this is a nice little trick, is when the Christian missionaries would try to convert like the Vikings and such, what they would say is, yeah. So Ragnarok, it's already happened. All your gods are dead. So this is the last era. This is the last era, and this is Jesus Christ. Yeah, that was how they used to do it, and they were used to just play with their own. They actually took they understood the mythology, and then just said, yeah, this is it. We're done. It's happened. It's in the past. And it's like, it's not to come. It's already been. And they were like, so that was one way of the trick. It was one little trick, but it was in that sense, it's like, yeah, you have all these things. So this idea that there being a Big Bang is I would say, to actually come up with it, you would have had to had a monotheistic culture.
And I believe, wasn't the Big Bang devised by a Catholic cosmologist?
Yes, Lemaitre. Yeah, he was a Catholic priest. The thing is, in the Einstein's equations, Einstein actually believed the universe was static. It was always eternal and just stayed the same. And he actually had a little symbol in there to make it the mathematics work. The problem is, he didn't realize it actually makes that completely unstable. Literally, the equation unstable. So if you have a very slightly positive, this constant was called the cosmological constant. That's actually what it's called. Things eventually, if it's slightly there, eventually things will just start expanding and expanding. They don't stay stable. It's a very unstable position. It's like holding a pen up, like on your hand, and going, nope. It's very delicate to keep it there, and so clearly things are just going to go out of whack, and then you get acceleration. So this is an idea of why we've got this called dark energy. The dark energy could just be this cosmological and this is why things are accelerating, expanding. It's not just like things are going faster; they're getting faster and faster. So that's another part of modern cosmology. But this is the thing. It's like, it's really fascinating that all this is kind of going on. So we're going back to Roger Penrose, because like we've talked about all these different things, these different ideas. Sorry if you've not been keeping up. People in, like, I know this is probably on YouTube, so comments, please just ask comments. Please do. Be easy enough. Penrose's idea is like, from a mathematical standpoint, his idea is like, okay, the far distant future and the far distant past look identical and mathematically are the same. So he's like, well, that could mean like our far past, which is like, okay, the Big Bang, and the far distant future, they have seen like this mathematical property. So hypothetically, the actual past, so you get to infinity, and he's saying that in his conformal theory, infinity is actually a place itself. It's not just like far away you can get to it, and just after infinity, so another infinity, it looks like the beginning of another Big Bang. So it's not crunching, it's more like continue, like heat, death, again to its dead, and then after, all of a sudden, when there is nothing there anymore, not even time is perceivable, like time is not kind of acting anymore, nothing there to act, all of a sudden things start again. That's his idea, at least.
Yeah.
I'm trying
so
to
it's like
even more.
It's like a Big Bang explosion that gets stretched so thin, right, that it gets stretched into like nothingness again,
into zero,
which is the same thing as the Big Bang.
Yeah.
Something
his
like that.
idea, yeah. It's
Yeah.
something like that. It is a bit weird. It is weird. I'll just say that. He thinks it's correct, obviously, but it is not a popular position.
But one thing that was interesting is, unlike the Stoics that imagine the same thing happening over and over and over again, eons on eons, is that he seemed to entertain the idea that the eons could be different. Right, like one of his answers to the fine-tuning argument was actually, and this was William's best point, is that, you know, William said one answer to the fine-tuning argument is that there's the multiverse, right, the mitosing popcorns, and we're just in a particularly hospitable part of the multiverse that is suitable for us. But really, there's all of these universes with different constants in them that could look very, very different.
Yeah.
And William said, you know, well, that's one answer, but you don't seem to be saying that answer. Oh, wait, you're just saying that answer, but except in your eternal recurrence eons. And
so yeah, like,
just
that's a very good point that Craig pointed out. Like, it is saying that, okay, you don't have to resort to having multiple universes and we just happen to be in the right one. You're saying that you just have a cyclic approach. Yeah. And we're in a certain cycle.
Right.
So
instead of horizontally there being a good place, it's just chronologically we're in the good place.
Yes.
Yeah.
And that's a different point of pointing. It's like chronologically there is. Now, what's interesting, also interesting to state with this, is for people with a multiverse, make a distinction here. So there's different types of multiverses. The one that I was speaking of, like the eternal inflation, that still would say there's one universe. We're just in a pocket of that universe. And that just expanded, and maybe another bit, there's another expanded, but we never ever see that pocket. So we could class them as different universes, but I would say that's still the main whole universe. The multi-universe thing is like, it technically comes from M theory. So M theory, for people who don't know, is this idea, they were trying to unify all the different string theories. So string theory is this idea, they were trying to figure out, like, there's many different things, but like it's a hypothetical mathematical model in physics. And they had all these different string theories trying to explain the world, effectively. And they all seemed to just say different things, and it seemed like none of them were related to each other. And then M theory came along saying, actually, this is how they're all related. There's all these dualities between the two of them. They're literally dualities, like you can just draw them across. And the kind of collecting thing of all of it is called M theory. And this M theory idea said that, okay, great, you can have universes with 10 dimensions. So in each universe, we call this a brane. Yes, they call this a brane, a p-brane or something like that. And then you just have all the universes kind of stacked on top of each other. And there's a very large number of these universes you could have, these different branes. So we live on a universe p-brane, what they call brane, like a membrane. That's where that words come from, by the way. Membrane, that's what they mean.
B-R-A-N-E.
M-B-R-A-N-E, brain,
Yes.
like membrane. Like that's what they call them, brains. I'm not a string theorist, but I'm trying to.
It's fine to call it a P brain, a P letter P B-R-A-N-E, because it sounds like the insult of calling someone a P-E-A-B-R-A-I-N.
No, it's well done to these people naming stuff. But that's what they're saying, and then you got these different things. So there's different multiple universes, and in these universes, they have different properties to them. That's the thing. And by the way, that might not be an infinite number. It just means it could just be a very large number. So it could be finite in these string theories. Like there's actually a finite number of universes, which is interesting to say the least as well. Mm-hmm. It's probably just because there's only a certain amount of configurations you can have. And the reason why is with these string theories is that you don't know which one is the correct one. You just have all of this pops out. You just don't know which one's the correct one. And it just and then the argument, which is the fine-tuning argument, is that anthropic one is just, we just happen to be in the one that we perceive. Like and it just works because the constants were just right, so we could perceive it. And I'm thinking, that doesn't explain anything. That's a cop-out. I know the M theory does come from actual like mathematical models. It's not something that they just pulled out of someone's brain. It does actually come from like the mathematics of a certain hypothetical model. But it is more of a still like, great, but that doesn't explain why those are the parameters for us, conscious life. It's still the whyness is that it never explains. It's just a cop out, and it doesn't. Again, it has no explanatory purpose to it. It's more, it's just happens to be it. Yeah,
it's a verbal description solution, but that doesn't have any oomph to it. Yeah,
correct. There's no oomph to it, and many people are satisfied by that. And I'm like, really? Because he's just saying, just the way it is, just is. And it's like, that's why I keep bringing it up, because it's like people keep asking why, like a 4-year-old. They go, why? And some people never stop, but some people go after that and go, oh, okay, that's just how it is. Okay. And hopefully I'll never be stopping why, even if it just annoys everyone. I'll keep going. I want to be that 4-year-old. But yeah, if that makes sense. I'm probably rambling now.
No, that does make sense. That is interesting. So I guess, is there any explanation from Sir Roger or any other physicists why, if there were these successive eons, why they could or would be different from each other? Nope.
So I can make an idea. So this is one going to get similar to like Stephen Hawking's view, is that the particles, all the constants were in like a superposition state. So they could be in any position. And then eventually they just collapsed randomly, effectively, into those positions. And the one reason we're observing it is that to be consistent with the past, they've had to have collapsed in a certain way. That's one way. So when it is in the future, they could have collapsed slightly differently. Like I'm doing a collapse model of quantum mechanics here, but that's, yeah.
In between the aeons, there's an opportunity for recollapsement of the...
Yeah, so the wave function, they're already in superpositions, and okay, so quantum mechanics is bizarre, so it really is. And if you don't
for
know,
me as a statistician, it's like
I could actually explain it to you.
You pulled a number
actually
out of a random number generator.
No, let's say okay, so a wave function is effectively just a kind of like a Bayesian probability distribution.
Yeah.
At the end of the day, it's just probability-based distribution, and then all of a sudden, like, if I'm going to keep with the collapse theory, I know this is not necessarily everyone's position on this, but let's just keep it simple. It's the one that people get taught. Copenhagen theory, which is the one that still get taught in schools. So what happens is randomly one of the positions just collapses, so it becomes
you take a draw from the
you take a draw, so it's the distribution, and all of a sudden you measure it. When you measure it, it collapses into one of the states, and it is that state now.
Somewhere along a bell curve.
Yeah.
In proportional probability to the distribution as defined.
Yeah. So as soon as you measure it, it becomes one that value in the distribution. So you measured where it was. That's the collapsing thing. Exactly.
It's more likely
so the idea
to be
is
in the center.
Things could be always in. It could always still be in this distribution. This distribution evolves and changes over time. Is one way of thinking about it.
The statistical distribution changes.
So this is what a wave function is in quantum mechanics. So that distribution changes, right?
Well, that's weird.
Yeah. It is weird, yeah. So it's that's one way of thinking about it. I think that's the Heisenberg way, Schrödinger way. The Heisenberg way is that actually that's fixed, and the operators that we use change in time.
Doing statistics while playing jump rope.
Yeah. So it's like, but that makes perfect sense though when you think about it. So let's say you've got a particle in a box, and you want to know the probability of the position in that box. Well, it might be, because it's a particle in a box, it could be here more likely, and then the next second it's there, and it's swinging between the two. So the probability changes over time, obviously, right? There's no problem there. Like the probability distribution is changing. But sometimes it may be changing with time, but when you take the absolute value, it's actually fixed. The absolute value of it, because in fact, these wave functions are complex numbers. They're not real numbers. They're complex. It's very weird. This is how reality works. It uses complex numbers for some reason. Thanks God. It's the best way of answering. I get this is the whole thing. It just happens. So this is the distribution. So you're measuring things, but it's the weird oddity of them. So they have sometimes the interpretations is, okay, you have this probability distribution, and your idea is actually it is in a superposition of both states. So it's not just like there's a 50% chance it's here and a 50% chance it's there. It's in a superposition, so it's actually in 50% states in both states at the same time, which is weird to say. And it's very hard to think of like a normal day analogy, really, if you don't know any physics.
You just end up talking about cats that are dead or alive.
That's a bad example. I know what they do. That just never helps. But just because it's a wave function, you can always explain waves. Like, okay, sound is made up of different types of waveforms, isn't it?
Yeah.
And like, it's not just one pure tone, like you're playing a flute. That's a very pure tone. But a piano, if you hear that, you know it's a piano because you can hear it. And the reason why is you're hearing all the different frequencies inside of it.
Yeah.
So on all those frequencies, those different waveforms are in a superposition together. That's actually what a superposition is. A superposition of different frequencies, effectively.
All right, so octaves or some, it's
yeah, so you
like
got
stacked octaves,
harmonics, octaves, all
harmonics.
that
Yeah,
stuff.
yeah,
Yeah, so you're hearing all these different things together, and all those waves added together they're in a superposition together. That's what it makes sense. That's a superposition. That's in the classical sense. So hopefully try to explain that term. I'm probably doing it poorly to people. It's one of those where, like, yeah, you don't learn this overnight. It's not like this is something you learn over a few years, and then even then you don't learn it. But yeah, that's kind of the idea. So it's kind of like it could have been there's different possibilities, and they just collapse into it. And then back in the past, they're still evolving, and then they could have collapsed into something different randomly again. So it could be purely random what they do. That's one idea. So that's kind of summarize what I was going on a random tangent there.
So where did we come back to?
So where do we come back to? Penrose's view. So he's just not doing a multiverse view for his fine-tune argument. His is pretty much just a cyclical one. Like we've got one universe, but cyclics, different eons will have different constants, and we just happen to be in this eon. Is his view, maybe?
So it's not. It's kind of like the Stoics, but kind of not like the Stoics, because we don't just replay the same show every time.
It's not exactly the Stoics. I would say it's closer to, say, maybe Norse mythology. Like it's not necessarily not exactly always the same eon. Like, but things happen again, but they're slightly different every single time. Maybe.
Yeah.
And maybe that's the case. Like you gotta. It was interesting. The Stoics did have like they didn't really believe in free will. Obviously, they're kind of like.
Yeah.
That's the thing. They don't mean it like the libertarian sense of free will I meant, but this is just how like it was determined as destiny.
Yes, providence.
And providence, yeah, that's the better word. Providence. And it's very interesting to say, like, and then again, William Lane Craig eventually tries to question, like, Roger Penrose later on, saying, "Oh, do you believe in free will?" Like randomly, just kind of not right. It wasn't random, but it was nearly random of a question.
Yes,
he was trying to like, well, if you believe,
I guess the free will is sort of it touches on the mystery that connects the mental to the physical, right? Yeah. That's sort of what the free will question.
Yeah, and that's Descartes' question.
Yeah, yeah.
It is Descartes' question. It's what not even that. It's also like Augustine's question. It's many philosophers. They've always had this mind-body problem and also the free will problem and what it is. Many people get to the conclusion there's no free will. Some people go to the Calvinist position, which is the compatibilist position. It's like, well, we've kind of got a free will. It's like, oh, that just means you don't. Sorry, Calvinists. I think you're wrong. Or we can go to the libertarian position. It's like, so actually, no, we have a free will, and it's like, and then you have to do different forms of it, and like, it gets a bit confusing. Like, I'm personally a libertarian free will chap, and actually agent causation chap as well, which is probably not that common of a position.
What do you mean by agent causation?
So, not instead of compared to event causation. So event causation, like, okay, this event caused this event, and that event, and that event. And that approach is very susceptible to Hume's argument. So Hume was kind of like thing. It's like, so how do you know they're actually events and they're actually caused together? Is the first problem. Like, and there are two different answers to the question. There's one of them is the Kantian argument, and the other one is the Thomas Reid argument. And I actually prefer the Thomas Reid. Thomas Reid, I think, is correct. Got the book on the side because I actually prepared for this. There's the good book for Thomas Reid, Inquiry and Essays. He was a Scottish philosopher.
Aren't they all Scottish?
Like Hume. Yeah, contemporary of Hume. And he was actually more popular than Hume at the time as well. What was funny, though, is that Hume got popular in the 20th century for people like G.E. Moore, which is interesting, part of the Thomas Reid tradition of all that weird stuff. But so it's kind of a bit weird. But the argument, he was like trying to argue the thing. But the thing is, Thomas Reid's position is, well, I know stuff about my own mind and how I work, and I understand about causing things. Like I understand causation. So I have this, I'm generalizing very dumbly, but I have this idea of event causations. I'm an agent causation. Another way of putting it is this, that you are a prime mover, effectively. Like you are in the image of God, you are a prime mover, you are able to make decisions which are not a function of the past, is another way of putting it. And with events, if you can do if you do a physicalist approach, like, oh, this thing was determined by this thing in the past, which was determined this thing in the past and this thing in the past, and it's these causation going on, there's events going on. They don't have to be temporally, this is actually a very important thing that Rob Penrose talks in there. You don't have to have a temporally ordered, so one thing doesn't have to occur after the other. Special relativity says that A and B could happen the other way, depending on how you look at it. yes, that's really weird. So you can actually, this is always a little thing you can actually do, is a little thing to show that things don't have to be temporally ordered, but they are causally ordered.
Mm-hmm.
So you could have, like, say, two, let's say you have, are on a train, and you have 2 lights flashing. And if you're staying still, they would flash at the same time. But let's say you were moving towards one more than the other, ignoring the speed of light, ignoring like the light was going to try double distance, you would actually view them differently. Like, you would see one flash before the other. And depending on which direction you came in, they would look flash at different options. So you'd say, oh, that one happened before that one. But clearly that's dependent on your perception and your like relativity to the events. So there is, and this is the argument, and like Penrose does go on Craig on this, like saying, Craig, do you believe like there's a absolute time then? And Craig's pretty much saying yes. It's like, that doesn't make any sense. You're just wrong, effective Craig, Penrose, because that's like, special relativity tells us that things don't have to be temporally ordered, but causation does. So one thing, if A caused B, you cannot ever observe it that B happened before A. You can never observe that. But if A and B are not caused by each other, there's a possibility you could view one before the other, and another person could view the other one before that, and that'd be perfectly valid. So that's I've gone on a tangent with physics, but it also goes back to agent causation, because it's like Hume's argument is very similar. It's kind of weird actually, but like the agent causation is like, no, I have an idea of how I know what causation is because I am doing it. I also have control and know my choices, and I'm choosing those decisions as an agent. Sorry, I'm going on a bit of a tangent here, but I'm not also explaining it very well. I'm not actually a philosopher, so I probably will cock up a lot.
So agent causation is basically that you can make you as an agent can make a decision that causes things, but is not itself fully explained by the causes that came before you.
Yeah, so it's the idea. I'm just going to read the actual technical definition, which is still not great. It's an idea in philosophy that states that a being who is not an event, namely an agent, can cause events, particularly the agent's own action. So agent causation contrasted with event causation, which occurs when an event causes another event. Whether an event causation as a concept is logically sound is blah, blah, whatever, I don't care. So this is like Thomas Reid, Roderick Chisholm is another one who's viewed, I think even Bishop Barclay, I don't know how to pronounce his name.
Berkeley, yeah.
Him.
Well, but Berkeley, California is named after him, so I think it's Berkeley, but you Brits might pronounce it Barclay, I don't know.
It might be I thought it was Bishop Berkeley, to be honest with you, but I don't know if it's Berkeley or Barclay. It's
in California, it's Berkeley. In England,
yeah, I know. This is the problem. Like, yeah. I know the university is Berkeley, but then I don't know. I just names. You never know how to pronounce English. Can
I throw a theory of causation at you?
Please do.
All right. So, I was at a hospital and I was working on a project. And we were trying to make a predictive model that could give the right migraine medication to migraine patients. So there are 3 migraine medications, right, that are all trying to do the same thing, but are interchangeable, but no one knows which ones work the best, right? They've all been approved, but no one knows which one works better. Or if some of them work better for certain kinds of people, but not as well as certain other kinds of people. So you should give medicine A to these sorts of patients, B to these sorts of patients, C to these sorts of patients, or maybe B just works better than A and C for everyone, or, whatever, right? So what we would do is you would come in, okay, you're a new migraine patient, you're needing to be put on one of these prescriptions. All right. So we calculate, we ask you some questions and measure, a handful of variables. Say we measure 5 variables about you or something like that, related to who you are and your migraine symptoms or whatever. Right. Okay. We then have a model that at least so for the first time, right, it does a 3-way coin flip, right? A, B, or C. Okay. Yeah. From a random number generator on the computer server. Okay. We give you A, and then 6 months later, we ask you, did it work? Right, basically. Yes. We give you a phone interview that asks you a series of questions that basically comes to, it worked, it didn't work. But for the sake of this conversation, we'll just say it happens instantaneously, right? We just magically know right away whether or not it worked for you. Okay, and then we take that information we put that in
Yeah.
the data set. We say, okay, for this patient, here were their 5 variables. We gave them medication A, B, or C, right? And it worked or didn't work.
Yeah.
Right. And then we train the algorithm, right? And it's like, oh, okay, so it's starting to notice correlations. So then it might say for the next patient, it's like, okay, for you, this model is predicting that there's a 60% chance that A will work best,
Yeah.
a 30% chance that B will work best, and a 10% chance that C will work best. You flip a weighted coin, right, based off of those probabilities. And then you give the medication from the coin flip, and then you find out if it works. Okay, you add that new data point to the model, retrain it, right? So it's getting better.
Good old Bayesian approach. Yep.
Good old, yeah. It's pure Bayesian learning, right? It's called Bayesian adaptive assignment.
Yes,
is what that technique is called, and you can actually show that it is the fastest way to learn, right? And it's actually a wonderful way to conduct an experiment, because normally what would happen in experiments is you randomly do this for 1,000 people, right? But you just do the 1/3 for the whole 1,000.
Yeah.
And then you publish a paper. And then for the rest of the time, until someone does a better experiment, you just use the results of that one paper, right?
Yeah.
And so for those 1,000 patients, they were just subject to the randomness of the experiment, and everyone else thereafter is subject to the, but this adaptive approach gets better and better and better and better and better and better over time. And only the patients at the beginning are subject to sheer randomness. The later you are in the experiment, the more likely the algorithm is to give you the better medication, right? Because theoretically it'll converge on, which medication is best for everyone, or which medications work
assuming
best for
which those parameters and such. Which again, it has a problem with it though. That those parameters that you're judging by, hypothetically, may not even be the right parameters.
Correct.
And you have so many issues going wrong there. Like, you've already made assumptions about your testing, which is why the old traditional approach, where you have like a big sample of people and you just split it into 4 groups, not 3, because you need to check to see if the placebo effect is there as well. So you need to give them a sugar pill, then you've got pill A, pill B, and pill C. So you have 250 in each group probably, or maybe even the placebo group may be smaller or bigger. Sometimes you can vary, obviously. So you'd have to go through all of that trial. And then you'd also want to make sure there's a double blind thing going on as well, if you want to have that. So that's the old traditional approach. But with this approach, it's more of instead of everyone at once, you are building up as you go along. And there are problems with that, obviously, because you are already building with your assumptions. This one the old approach had virtually no assumptions. You were kind of like, which ones work? Let's see what happens. But you're not actually
but it's a one size fits all. It's
a one size fits all,
yeah.
Well, this one is meant to be a tailored thing, and you've got a hypothesis about what the parameters may be, and that's the point. But
so that's one problem is the variables that you pick, and then the other is the structure of the model, right? It is a Bayesian model, but there's an infinite number of Bayesian models.
Exactly.
Right? You could use random forest, you could use Bayesian logistic regression.
Yeah, you could do it like, we're going to put the model is like what their favorite color car is in there or something. And by the way, you may get a very good model out of it. It's like the problem is, you're right, that it's weird. There's no causal relation anymore.
So
and that's the problem.
Part of what I think agency is what's interesting, even in the just pure randomization versus this adaptive learning thing, is you need randomization, right? Because the function of the randomization is that it isn't one of the causes, right? Because you need to separate out the cause from why you got the medicine from the result of the medicine, because that the random number generator on the computer or the coin flipper, the dice or whatever, isn't causing the medicine to work or not, right?
Yeah.
Because that's the thing about randomness, is we know that it isn't the cause of the outcome, right? But these other things might be the cause of the outcome. So and that's what I think is interesting about agency, is that I actually wouldn't be surprised if the way that our minds work in some circumstances, or in many different sorts of circumstances, is that it's tapping into some sort of quantum randomness, whether it's, collapse or something like that in our brains. And that the reason why we care so much about free will and holding people responsible for their decisions is so that their learning algorithm can get the feedback on the decision that they made, right? Because for this algorithm to retrain itself, it needs to know what the outcome of its decisions were so it can get better, right? If it doesn't get the feedback of its decisions, it can't get better. And it needs the randomness to know that this isn't the cause of the outcome. And in the
Yes.
same way, the agent
But
needs
very
to
careful
know.
there. There's no technically mind there anymore, and nor is there morality in that statement. What you've said, there's neither there. So be very careful there. So this is kind of like an animal would work in a sense. Like evolution would train this thing to be better, and that whatever is more successful survives. Because
Yeah.
what survives is successful, obviously. That's kind of tautology. The survival of fittest. That used that tautology by Herbert Spencer.
No.
And yeah, that's all. So you train in this mind, and in many ways, your mind does work. Your brain does work that way. I should say, in your mind, your brain does work that way, and you're very careful about like how the structure of your brain is. I know my brain does this sometimes. Like I can just like, oh, I've noticed it that it's just kind of like worked on these heuristics which have built up over evolution, and I would heavily trust a lot of them as well because like they've built up evolution, they're very successful. I should probably trust a lot of those instincts and heuristics. But the problem is if you start thinking that way, that's how a mind is. Let's just say that's what the brain is, and that's how people's minds work physically. This doesn't ever get you to morality, ever, because it never gives you the oughtness.
Right.
It doesn't even tell you. Pardon me. It doesn't even tell you like you ought to do X.
Or well, and
it just says doing X will give you Y.
And to tie this back to the migraine medication machine learning algorithm, it is just hardwired as part of the algorithm to maximize the chance of success.
Yeah.
Right. You could turn it in one line of the code, you could just turn positive into negative in one line of the code.
Yeah.
Right. And then all of a sudden the algorithm would try and give you the worst medication. Right.
Yeah.
Or try and learn which medications,
because all you're doing is asking a binary question like, was this success? Did this get rid of your migraines or not, or reduce them or not? Like it's a very yes or no answer. If you were giving it more instead of binary option, you give it like ternary or quaternary or whatever. How many different options it could have been?
Or what's your change in the frequency of the monthly frequency?
Like if you start making it from discrete to like literally a continuous variable as well, it gets even weirder. So you're training on different things. So these neural networks, these machine learning, whatever you want to call them in general, these models, these things are being trained on a already a goal seeking stuff. There's already a certain goal it's trained towards to do. Now in the evolutionary sense, it's completely blind. You say blind watchmaker if you're going to do the Richard Dawkins analogy, but the view in that sense is I'm trying to think of the word, is that it's just whatever seems to survive was successful, and it will just, and anything that keeps surviving is more successful. That's kind of just what evolution is. Very in some ways, it's just bland.
I could quote myself from the Jordan Peterson, Jordan Peterson's favorite quote of mine, that the success of an embodied thing is a revelation of truth itself, right?
You could say that, and like in the sense,
and that way you can get rid of the blind chance thing.
The problem is, this is the thing, is even if I put my naturalist hat on still, I would say like, no, all that's just shown you is that under these conditions, this is what's worked to be successful. That doesn't even say there are other things that could have been successful. This doesn't even mean this is the most successful or this would work at all conditions. It is just like a fluke, effectively, or just like, oh, it just works for this. It works for this, and it's just a local maxima, effectively, or whatever. And this is the weird thing, is like I can take that hat off now. And I'm like, great, but you're not explained why any of that works in the first place.
Right.
Like it's kind of like there's no reason behind it, and I'm getting it all leads back down to like C.S. Lewis's argument for reason, really, which is the thing that always annoys me.
And where does purpose come in? Yeah.
Like, what are these purposes, these reasons?
What is this purpose?
Stuff?
Yeah. Because in that medication thing, it's already the fact that humans don't like migraine headaches, and that the purpose of the neurology department is to help people with neurological symptoms, feel better. and and all of these things, and then the money that funds the hospital and the research and the grants, right, and all of these things come into the purpose of why this algorithm exists, is because people don't want migraine headaches, right? And then but that's only one sub purpose of the larger human purpose. There's lots of things I want and don't want, right? And migraine headaches is just one of them.
And like and then not just that, it's like, you're looking for the migraine headaches and such, and it's like that's kind of the reason why you're doing things. Like, this is the thing that scientists seem to sometimes forget. You can do all like this purposeless thing, but like, you doing science is for a purpose. You've got a reason for it. And not just that, sometimes there's a means ends things, like there's an end you're trying to achieve and you're trying to find the means to achieve that end. And there's like, this is what rationality is, in my opinion. Like, that is what rationality is. Rationality is the difference. There's a difference between purposeful choice, purposeful human action, and reflexive human action. Like, reflexive would be if I hit my knee, but it kicks. I didn't choose that. That wasn't purposeful. But purposeful is like, oh, I've chosen an ends and a means. Now, I would say that rationality is also amoral. There's no morality in that system either. Like, there's no, ought to choose this goal. It's just, if you choose this goal, here's the means that might be the more efficient or less efficient. Like, it doesn't even tell you which one you do. It's just like, but the thing is that's what rationality is, that you're working with, you've got a purpose in mind that you are trying to achieve. And that may be not everyone's favorite definition of rationality, but it seems to fit quite a lot, in my opinion, and it helps. But it's that oughtness. It always bothers me. C.S. Lewis, he annoyed me for 11 months with the argument from reason. I couldn't find anything wrong with it. I found something wrong in the end, and then, but even then, didn't really find something wrong per se. Just, I found a flaw, and then I read other people and went, yeah, they already found that flaw. Damn it.
I should get going at the top of the hour. Do you have any closing thoughts?
Closing notes? This has been a lovely conversation. It's the first thing anyway. I'm sorry if I've gone a bit scatterbrained.
No, this was fun. This was fun.
This is very fun. But also, like, it was an interesting conversation. I don't like William Lane Craig at all.
Why not?
I don't know if it's just his Americanness with it's probably also, that's one aspect. The other probably is very evangelical, in the sense that he's trying to evangelize his position, trying to convert everyone at any moment he possibly can. And it's like, he's trying to do that with Roger Penrose. It's like, Penrose is not going to give a damn. He's not going to try and convert him. It's like, just stop doing it. It's the first thing. And there's also many other things. Like, also, I'm like, I've seen many of his arguments, and he's making so many logical fallacies as well. So I don't think he's actually that good of a philosopher, which I know many people are like, oh God, I really love him. I'm like, I've not seen him make a good argument yet, personally. That's why I don't really like him. But there are some, like, in that realm of theologians, like, I don't mind Plantinga that much, to be honest with you. I quite think he's quite a clever chap. I don't always agree with him, but I think he is actually very clever and well thought out and understand his views. But then William Lane Craig, I don't think so. in comparison, that makes any sense. Because I know you said earlier, like, you think you were supposed to like William Lane Craig, and I was like, and I'm going to ask you, why are you supposed to like him?
Because I'm evangelical.
But why?
Why am I evangelical? Or
no, not why you're evangelical, but why is an evangelical you meant to like him? That doesn't make any sense to me.
Because he's on my team or something like that.
Oh, he's on your team. That's why you meant to like him. I'm like,
yeah, that's really what it is. It is. Although, I'm a weird member of my team, right?
Yeah. Let's not go there, shall we?
Yes. So that's part of why I give myself the liberty to not like him.
Yeah. That's fine. You're already a heretic in many ways to many people. So.
And also, he's terrible on the Trinity. That's another reason why
I don't think he's good on anything. I'm not seeing him be good on one thing yet, personally.
Well, that's a good point. Yeah. I mean, he's not particularly good on the incarnation. He's not particularly good on the Trinity. I know that he's been focusing on Adam and Eve a lot recently. I haven't read any of those books because I just don't trust him.
What's he arguing for then?
That's what I want to know.
Actually,
I don't even know. I think he was trying to figure out, should he be pro-historical Adam and Eve or anti-historical Adam and Eve? And I'm not even sure which of those he picked. And honestly, I just don't trust him to be an interesting person on the subject, so I haven't even ventured to find out.
It's also one of those questions for me, at least coming from my background. I'm like, I don't even care about that question. That's just like the most stupidest question you could ask, in my opinion. Like the only people who care about this, in my opinion, are the people who think, yeah, it has to be historical, obviously. They're the literalist types. They're very fundamentalist types. And those are the people like Richard Dawkins would criticize a lot. And for good reasons. Like, I don't think he's wrong criticizing them. But at the same time, he's of that camp as well. He's just on the opposite side.
Right.
He's of the same group. It's just the opposite view.
Yes.
Still in that framework, which is kind of the funny thing. Like, the people that the New Atheists hated the most are their own camp, but effectively the other side of the camp.
Yes.
That's kind of my view. But yeah.
And William Lane Craig is kind of still in that camp. Although he's not fundamentalist enough for some fundamentalists, I know. There's some people who don't like him because they think he's a little bit too liberal or too loose on this subject here or there. But he is still kind of in that old school camp. And I think that's part of the reason what limited him from being a better conversation partner with Sir Roger.
Yeah, and again, it was from the start. It was like he was trying. I noticed the evangelism, and that's what I actually hate a lot of people. I don't care about evangelism because would tell you to F off. I would just say that to your face, like, stop trying to sell me your religion. I just want a conversation about topics. I'd like to know what you think it. Don't try and convince me. Like, and then we can understand where the disputes and like, find interesting things. Like, that's the point. That's what conversation's for.
Yeah.
It's not a debate, even though I think William Craig is so used to debates. Yeah, that's probably it. It's like
he's a debater. Yeah,
he's still bad at them. He's so bad at them though. Like there are better philosophers out there and theologians. Just there are.
But what's interesting is somehow William Lane Craig found himself to be the person on those stages so many different times. And I mean, I thought just
that American charismatic view, like they're here, and that big American grin, and the sorry, it's just
he's got very memeable facial expressions and eyebrows, though. So he gets in a lot of gifs with his eyebrows because his face.
I can do those eyebrows as well. Don't worry about that.
I thought Justin Brierley did a pretty good job moderating.
Yeah, he was very good moderator. And not just that, he actually seems to be read about many of the physics terms as well. And, like, he was actually trying to understand it very well, which is I was a bit surprised. Like he actually understood a bit, but maybe because he's probably done this job enough, he probably learns it. But even then, it's still okay.
Unlike the Babylon Bee, he does his homework. Yeah.
Unlike the Babylon Bee, where they one of them got fired because they were that bad and they didn't do any homework, or they didn't take it seriously. It's like, no, you're living in, what is it? He's the second richest man in the world and clearly one of the smartest men in the world. I'm like, yeah, you should have done this better. So I won't rant about that. But yeah, this was fun anyway. This was very fun.
Yeah, this was fun. All right. I don't have much else to say. About time to go. I'll send this.
We'll
over
leave
to
it
Jeff.
for another time, maybe for something else.
Whatever
Jacob goes, hey, this guy's.
Yeah, Jacob, we covered at least 15 minutes of this hour-and-a-half long conversation.
I think we've covered all of it technically, but
yes.
It's just there was only like 15 minutes that we really wanted to watch.
Right. Yeah. So the purpose, this was a means to the end of pleasing Jacob. So I hope that we have accomplished our goal.
And I hope that was a good thing in itself.